Hello everyone. Alright, so I have a forecast package prepared for the storm as of what I'm seeing right now. I do have to say this is probably one of the most complicated forecasts I've had to come up with in the last month. There's a lot of things coming into play here, and the models are handling them in different ways, so it's very hard to come up with an accurate forecast, but hopefully as we get closer to Tuesday it'll become more apparent what's going to be happening. This is the latest run of the American model, though. Basically, there's still going to be 3 pieces of energy. Well, actually, I think it's going to be more like 4. Hold on a second. That's too far ahead. This is where we were. Alright, yeah. 4 pieces of energy. This piece, then this piece, that piece, and then a piece all the way up here. Well, actually, these 2 pieces are associated with that regular piece of energy over there. So it's just a couple of branches of this. But this is all going to come together. So these 2 pieces come together first, and that's going to form your storm along the boundary between warm and cold air, which is going to be down here during the day tomorrow. As you can see, let's take a look at our high pressure map, low pressure map. You have high pressure setting up. Your 10-20 line comes all the way down to here, so that's how far south your cold air is going to be, very far. So then these 2 are going to come together. That was too far. Alright, so this is where we were. Alright, so those 2 are going to dig south, they come together. Okay, and your storm is going to start to form right down here along the Gulf, and then it's going to move east. So right now we're just east of Florida. Your storm has formed. Look at your precipitation map for the American model. There it is. And notice the tilt of the trough is still not negative just yet. Well, here's the thing. So you do have, this is your main piece of energy here, and then you have another piece of energy coming in from the north and west. And at some point, these are going to come together as well. See, they're pretty much come together there. But coming back here, what's going to happen is this is going to form one low off the coast, right? This is your main piece of energy here. Then this other piece, this other trough coming in from the west is going to form another thing that we call an upper level low. Not a mid-latitude low, an upper level low. So this is in the upper levels of the atmosphere. That might bring in some sneaky snow across, the mid-Atlantic as that moves east. And the reason I'm worried is because models, the weather models don't have good sampling of the upper air. So they typically don't deal with the upper level low in the right way. Like they usually miss the repercussions of that development. And I read online, I was reading up on this because it's part of my forecast here. I read online that sometimes the models don't deal with an upper level low the correct way, and that consequently brings more snow or more precipitation in areas that weren't expecting it. So I will have to say I think the European model deals with the upper level low pretty well. I don't think the other models do. I don't think they deal with it correctly. But anyway, this is your main trough. You can see it's starting to become negative a little bit, but it's not really enough. It's still more neutral. So if this were to become negative quickly, this would move up more to the coast, but that doesn't seem like it's going to happen. None of the models are indicating that. So this is going to be a track basically out to, well, not out to sea, but pretty close to that. Definitely not close enough to the coast to bring the impacts that it could if it came close enough. Sorry for the shakiness here. Alright, there we go. Okay, so here we go. So those 2 troughs are going to come together. This is still behind. You're going to have an upper level low associated with this that's going to be coming towards your main storm, which is out here. So as these pieces of energy combine, your storm off the coast here is going to rapidly strengthen, and then consequently it will close off as the 2 troughs come together. And that's what we're looking for. So the couple of things that are going to be key here is when do the troughs come together. That's going to affect the track of the low. And how quickly, again, does this trough become negative. that will affect how much moisture is pulled west from the storm and spewed out over coastal sections of New England. And, if these two come together later, then the upper low might actually, it might have a repercussion farther north if these two disturbances come together a bit later. That's another thing you got to watch. Like right now, I think the main trouble with the upper low is going to be back across West Virginia, southern Pennsylvania, maybe northwestern Virginia, but I think that's where your main thing is going to be with the upper low, and then the main storm off the coast. It's not really going to be too much of an impact along coastal New Jersey and Delaware and Maryland. It'll start to really ramp up over eastern Long Island, maybe eastern Connecticut, extending up into eastern Massachusetts and eastern Maine. That's really where the main storm is going to play the biggest role, but even there the impacts are not going to be as great as they would be if this thing were to track a little bit further west. So let's talk about differences between the model runs yesterday and today. And the main difference is, let's take a look here. Alright, so this is where the low pressure is closest to us. The two troughs have officially come together at this point. Alright, you can see it's starting to close off now. You see that signature in the American model. It's starting to close off. Yesterday, but at this time, it was further into the process than it was now. It was closer to closing off now. The difference between the models yesterday and today, yesterday, especially the Canadian model, for sure. The Canadian model had this thing already closed off at this point. But all the models have this low pressure closing off a lot later and further east than they had it closing off yesterday. And consequently, your heavy precipitation shield, as this closes off, is going to be pulled further east because this is closing off the coast further east as well. So that's the problem. Yesterday I really thought that all of Long Island and New York City were going to get 6 inches of snow. It doesn't look that way now because this low is closing off further to the east and not as early. If it closed a little bit earlier, then it would close off further to the west and more snow would come in. You get a big snowstorm, but that doesn't look like it's going to be the case. And I think part of that reasoning is because the western trough and the front trough don't come together till a later time as well. I think that's really the main thing, and this strengthens a little less rapidly as it comes up. It will start to really ramp up, east of Massachusetts. That's where the central pressure is going to drop into the 950s, 950 millibars. Maybe not that low, but into the 950s. So I'm telling you, if you're upset that, we're going to get snow out of this, don't be, because it's pretty much a miss. Like, if this came further west, it would be a huge storm. But nonetheless, we will be getting some snow. So that's the difference. And also, I've noticed that this tilt is not as negative either in some of the models. Like the Canadian model had the tilt of the trough a lot more negative yesterday, and now it's not that way. It's still negative, but not as much. It's a little less negative. And that means the storm's going to be tracking further, a little more of an easterly than a northerly track. And consequently, it doesn't close off as far west and as early. Okay, so those are the differences in the models. Alright, so you can kind of see here. Let's take a look at the Canadian model. Okay, so this is where the low is closest to us. You could see, remember yesterday that there was a huge signature in here with this thing closing off? It's not there anymore. It's really not. And then take a look here. Look at how far east the Canadian model has this going. This is way off. Yesterday the Canadian model had it over here. And now all of a sudden, over there. It's way further east. Part of the reason for that is because, again, these two troughs are coming together later than they were showing in the models yesterday. And this tilt is not as strongly negative as it was yesterday. Okay, so we don't need to keep reiterating those differences. I think I've touched on it enough. But what does that mean? Now, I've gotten access to some better representations of the European, Canadian, and American models here. This is the European model. This is mean average sea level pressure and precipitation. This is all precipitation, the red and the green. This is 7 p.m. Tuesday evening. You can kind of see you have two areas of low pressure here. This one over here, this one over here, and then another one back in there. Now, this is actually your western trough here. As this trough comes together with this, an upper level low is going to form, and that's what this second area of low pressure over here is. And I think the models are not dealing with that in the right way. The European is, I really think, but the GFS really doesn't show any precipitation coming into the coast here associated with this upper level low here. And I think that's a problem. I think the GFS and the Canadian models are making a huge error with that. The European does not, however, because look at this. 1 a.m., it's still here. At one point, this is going to combine with the main low. Alright, so keep that in mind. But, you know, at 1 a.m., it's still here. The other models do pick up on this being here. However, the European is a little more aggressive with the precipitation coming in, and I kind of agree with that. Because if you have another area of low pressure here, it's definitely possible that more precipitation is going to spread back westward. And also, I think some of the models are not taking into account the negative tilt of the trough. That's another thing. So that's why I'm kind of leaning with the European here. And then as you can see, the upper level low goes away, and then you just have your main storm here. And you can see heavy snow makes it back into central Long Island, Connecticut, eastern Massachusetts, back up into Boston, and then back up along the coast of Maine. This is the next run. So you can see this is a really strong storm. It's just not coming far enough to the west. But I think there's two ways that more snow could get actually, there's a few ways. There's a few ways that more snow could get forecasted in this area. One, the upper level low is underestimated by the models, and it brings in more snow on the western side. Number two, if the low starts to close off earlier, then further west, then that would also bring more snow in here. Again, the upper level low would probably already be in it by then, but the closing off of this low would also, if it comes further west, that would bring more snow. And then if the storm itself tracks further west, that would bring more snow. Those are the three ways that more snow would come in. Now, if the current trend continues, I don't think that's going to happen. The current trend is to bring this storm further east, to have this trough combine with it a little bit later. I believe later. You know, I gotta be quite honest with you, I'm still having trouble deciphering what these models are showing me, but I really think it's because this trough comes in a little bit later, and the tilt is not right, and that's why it goes further east. But yeah, if the trough becomes more negative, that's another thing that would bring in more snow. Alright, so, again, I hope that wasn't too scatterbrained there. So now that we've looked at pretty much all the models, in the next video we'll talk about snow amounts, and I actually have this new thing on this website called Weatherbell that shows actual snowfall amount representations from each of the models, so we'll definitely go over that. Alright, thanks for watching.